Alright, this video is going to be about unraveling the spaghetti of observability and monitoring tools in DevOps in 2025. It's a huge mess and I'm going to demystify everything for you. It's not going to be a tools demo, it's going to be about knowledge. So if you need to get primed on observability and monitoring, maybe you even have an interview or something, this is the first step that you need to know everything high level and fill in the blind spots as well that you may have. So this is what we're going to do today. We're going to spend a little bit of time, very quick recap on some of the basic definitions and the infra types, because a lot of people get this wrong and you got to get this right. And also on classical infrastructure observability. I'm talking about on VMs, but this will be very quick, these first 2 points, and believe me, it'll be well worth it because a lot of people get this wrong or have blind spots. And then the majority of this video is going to be on Kubernetes observability, because it's more and more common you're working with microservices in Kubernetes. We're going to cover two stacks, which are the ones that you see everywhere in different workplaces. Either going to be Elastic Stack, aka ELK, usually in more bigger businesses, or it's going to be more commonly and increasingly Grafana Labs and Prometheus type products. For example, the LGTM stack, Prometheus stack, etc. And as I say, this is not going to be a tool demo. This is going to be like filling in those gaps in knowledge that you need to know about observability, monitoring, etc. I will do a future part 2 hands-on, which is probably going to be some combination of LGTM stack and Prometheus. So I'll let you know a bit more about that as we get to it here. Let's get started. So if you haven't already, by the way, we're almost 200 subscribers and almost 100 videos. Please, if you haven't already, subscribe to the channel. Now, here is a quick recap of the concepts. A lot of people get this wrong. The overall thing is called observability, right? Think about it. Observe, it's kind of like visibility. It's about wanting to see everything going on, data-driven, all that kind of stuff. And it's made up of 3 things in order of importance: monitoring, logging, and tracing. Monitoring, it's not that confusing really. It's just, think about the word metrics. And metrics are things that you can measure. So typically, for example, in infrastructure, it would be CPU, memory, disk, network, e.g., percent CPU utilization. Now, a subset of monitoring, which is normally included in monitoring, is alerts or alerting. And that's simply notify when a condition or a particular threshold has been reached. For example, when the CPU percent is over or equal to 99%, then send an alert. And alerts are mostly triggered off of metrics. You can have it so that an alert is triggered when a keyword appears in a log file, for example, but usually alerts are related to monitoring, to metrics within monitoring. Now, next most important is logging, and every application that's developed properly should be logging. And logging, really, when we talk about observability, is all about sourcing the log files from wherever the workloads are. Can be a VM, it can be a microservice, and then centrally storing them, right? And there's typically 2 types of log file. There's a log file that relates to the service, to the application, and there's also related to the system, to the infrastructure that it's sitting on. It could be a virtual machine, or it could be something else. It could be Kubernetes node or something like this. So monitoring is more important, but logging is pretty important as well. And originally what drove the central store was like compliance, okay? But it's become more than that in recent years. This has become super useful, especially now that we are able to index and search our log files and stuff like that. And the final one, part of observability, is tracing, also known as distributed tracing. And this is where you're able to trace, to see your requests within your application happening as it goes through the application. You know, you get a request coming in, right, from the load balancer or whatever, it enters the app, and you can follow the state of the request in real time. And with this, you're able to see where things go wrong, basically. So latency, it takes too long, or the throughput, there's a bottleneck maybe, and you need to fix that because otherwise the requests are slowing down. And also there could just be straight up errors. So these are typically the 3 things that you would look for in tracing. Some companies are not very mature in their observability. They don't even do tracing, but almost every company will do monitoring and logging. And they're all part of observability. Very important to recap that, I think. A lot of people get that wrong. It could be a question at interview. Now, the other thing I want to quickly recap is classical infra, especially for those of you with a software development background, software engineering, and maybe never really worked with old school infra. You could have some blind spots, and I think this will be super useful to you. So, monitoring on VMs is typically you've got on-prem and cloud, right? And on-prem, the ones that you're going to hear most of the time, Zabbix is like the leading product right now. And it's open source, I think. An older one, which is still used quite frequently, is called Nagios. So these are the two names you're going to see. Go ahead, go look them up and do your own research. I just want to let you know. Cloud also has its own built-in monitoring. So typically, for example, for Azure, it's Azure Monitor. For AWS, it's CloudWatch. I just sort of mentioned that there is a difference, but a lot of jobs as on-prem becomes more cloud native, and a lot more DevOps jobs you'll see on-prem. You got cloud repatriation going on, moving away from the cloud. You're going to get exposed more and more these days to Zabbix, which is pretty much the leading, I think, open source on-prem monitoring suite that there is now. Now, you can poll from a central location in order to monitor VMs, but usually you want to install an agent and it will send back much deeper insights. The classic example is that from outside you don't know what the memory usage is, right? That's just one classic example. But in general, you should always install an agent. It's not too much overhead. Now, there is another type of monitoring that you'll see quite commonly in the classical infra way, and that is network and other devices. And one very common thing that you can have is something called an SNMP trap. So SNMP is a type of protocol, and I give you an example here. You can configure a Cisco switch to send this SNMP trap, which is basically an event-driven message. So for example, you can tell the switch that whenever the link status changes, the link goes up or down, that it should send on this event an SNMP trap, a message, and then this message, you'll configure it to point towards some upstream management system, IP address, maybe a domain name, and that way the centralized management console, it doesn't need to keep polling all of the network devices, because instead this message will get sent to it. So yeah, it's unnecessary. Another thing to know about logging on VMs, and I only know about Linux really, it's a little bit different on Windows, but on Linux there's always been something called syslog, and within syslog there are a number of ways. It basically means centralized logging for Linux log files. So just something to know. If you need to know more about it, go look up syslog, go Google it, go use AI, whatever. Great. We got that out of the way, but I felt that was very important to do. Let's move on now to Kubernetes/microservices monitoring. And there's two types I mentioned. There's Elastic Stack, otherwise known as ELK, and there's also the other one we're going to look at, the more kind of lighter and more very popular now, open source Grafana type products plus Prometheus, etc. We'll start with Elastic Stack because this has been around for a very, very long time actually, and commonly called ELK. This is more common in enterprise, and a big reason for this is because, as you'll see, there's quite advanced search functionality. Also, there's you have the ability to do a lot of clustering. You can do this at some seriously large scale, which you can't really do with the other products that we're going to look at that are more common in startups and scale-ups. So I want to talk about ELK. The clue is in the acronym here, right? ELK. Let's forget about the L for a moment, but let's look at first the E, Elasticsearch. Now, this is the main data store for this whole suite, and it's actually really, the clue is in the word search. It's a search engine, or to be more accurate, it's a search/analytics engine. A bit like an advanced Google. You can actually search it from the front end. You can put in this kind of advanced type of query, and it can store everything. It can, it's suitable for getting logs towards metrics and traces, those three things that we mentioned before. And it will store them in the form of documents. I think they're JSON documents, but it will also create its own indexes. And if you don't know, when you search Google, right, you're not literally searching every single page that it ever sucked in. Google makes indexes, and indexes are quicker to use in your search. They aid your search and will return it within a fraction of a second. And that's what this whole thing does, this search analytics engine. It sucks in all this information. It probably has to do some transformation. It gets them into documents. From those documents, it creates indexes. And from there, you're able to search them. Now, something very important, right? What we're saying here is this is all kind of behind the scenes that typically users of your application wouldn't know anything about this, right? But what you can do is you can power your applications with this. So you can put in Elasticsearch, not just your logs, your metrics, your traces, but you can put your product information in there. And then let's say you've got like a kind of Amazon style site. Someone can search for a product, and behind the scenes you can power that with your own search engine, which is actually Elasticsearch. So it's not only for logs, metrics and traces, but for other stuff that you can put in it and power your application with. That's also why it's more common in enterprise. Now, the K is Kibana. and it doesn't really give you much of a clue, but it's basically just a UI, okay? It's a front end. And yeah, it comes bundled with this. It's made by Elastic. But look, that's not to say that you have to use Kibana. There are alternatives, and some of them are popular, but yeah, this just comes out of the box in the Elastic stack. It's there and you can use it. Okay, so far we've basically got this data store, this back end, right, for all our information, and we've got a front end. Now, what about the stuff that we already talked about? What about the metrics, the logs, and the traces? Well, we start off now with the L. So although it sounds like ELK already, you'll see that these days Elastic Stack, they just like to talk about their product being Elasticsearch and Kibana, and they call everything else an integration. It's almost like they're kind of relegating it to the back seat. And they have about a dozen integrations, but obviously, probably the most important one historically has been Logstash. So what is Logstash? The name is terrible, right? It sounds like a place where you stash your logs, but it's not, because obviously you store everything, including your logs, in Elasticsearch, which again is not a great name. Although it's a search engine, it should be called Search Store or something like that. Logstash is not a place to stash logs. It is not a store. It is a data processing pipeline. Right, and the typical configuration will be some input source, and then you filter it. And there's lots of plugins there, and then an output. So what you'll have here is like you'll be able to input like many common things, like for example Nginx logs or something like that, and you'll be able to transform them, and then tell it, output it, send it to Elasticsearch. And so there's lots of common different types of logs that you can use Logstash to convert. Now I want to say here, right, it is optional. Elasticsearch is capable of handling from your apps or your infrastructure, sending directly to Elasticsearch. You don't have to use this data processing pipeline unless you really need to make some kind of transformation. So that's just something to mention, that in your use case, have a look. You may not even need to operate Logstash, but again, such a terrible name. It's got nothing to do with stashing logs. I think the reason it's called this is because most commonly, if you need to do data processing, it will be on logs. So it's really should be called log transform or log transform optional or something like that, with common support for many common types. That's really what it should be called. It is not a stash. It is not a store. It's simply a data processing pipeline that you may not even need. Let's move on. Now, this is very important, right? Continuation of the integrations. We have something now called agents. Now, one of the really bad things about the entire observability world is that there's multiple names for the same thing when it comes to agents. So agents, data shippers, collectors, forwarders, they're all the same thing. What do they all do? They all connect to the source of logs, metrics, and traces, and they collect and ship or forward all of these three things to wherever they need to go, to some destination. So that can be, in this case, Elasticsearch. But even when we move on and we look away from ELK, we go to Grafana products, you still need to have collectors / shippers / forwarders or whatever. They always do the same thing. They connect to the source wherever wherever this stuff, this data originates, and they help transport it to wherever it needs to be stored. Remember, Elasticsearch is a store. So in this case, Elastic Stack comes with a number of agents, shippers, collectors, whatever you want to call them. So the one that they keep trying to push lately is called Elastic Agent, and it's called a unified agent. Whenever in tech you see the word unified, it tends to mean all in one, handles everything, right? And Elastic Agent actually comes in two forms. One of them is called Fleet. This means centrally managed. So when we say managed, we always mean like policies. You know, you're managing a bunch of agents out there connected to the source of all the logs, metrics, and traces, and we want to manage via policy using some central console. Especially in a big company, you're probably going to want to use Fleet. You can also have standalone. Now you may be asking, if it's standalone, what policy will it use? Well, basically, I think it's a JSON or some other config file that you can push out. You push out to your endpoint where that contains producing the logs, metrics, and traces. Also has this agent installed, and you push out this configuration file that then the agent will use. So you'll have some other means of pushing that out, maybe configuration management or something else. It could be like SCCM in the Windows world or something like that. So that's the Elastic Agent. Now, what is older, simpler, older but lighter, and still in common use today is something called Beats. Okay, funky name. Beats is actually two products, or multiple, actually even more than this, but typically you've got FileBeat, you've got MetricBeat. FileBeat is a collector or forwarder or shipper, whatever you want to call it, for logs. And typically you might install this like on a VM, but you can also, it also can be used in Kubernetes as well. I think it's, what is it called? Pretty sure it's installed as a daemon set. Metric beat is similar, but for metrics. And this is a collector forward or whatever for getting process system metrics. So, like this process related to individual services, or system metrics like related to like the underlying OS or whatever. And again, you can have this in the old school world on a VM, or you can even have it like as a daemon set as well, and it'll tell you about underlying node metrics, maybe also microservice metrics and stuff like that. So you got file beat for logs, metric beat for process / system metrics. Logs metrics, right? What's missing? APM tracing. APM is the integration. That's what they call it, APM. APM has a generic meaning as well, but they call their integration APM, and what it will do is it will trace app requests in real time. We mentioned this earlier, latency, throughput, error rate. I think it may do more. So APM technically, I think it stands for Application Performance Management. It's a broader field than just tracing, but tracing is a great deal of it, a large part of it. And so in general, you can just know that for Elasticstack, the APM integration is for tracing apps. And by the way, what I want to mention, I did skip over this briefly, but going back again to shippers, collectors, forwarders, whatever the hell you want to call them, for a very simple environment, you may not even need a shipper. You may be able to connect the source of the logs, metrics, and traces directly to Elasticsearch instead, okay? Or actually, to be more specific, what I said here is that these things are used to send things to Logstash in case you need a data pipeline, or to send them direct to Elasticsearch. So you can go direct to Elasticsearch, or you can go via an additional step in the middle, Logstash, because you need to apply some transformation. However, you don't necessarily even need these to send them to either Logstash or to Elasticsearch. You can actually, in a simple environment, do away and don't even use any of these agents, these shippers, these collectors. You can just send it direct. That might work in a simple environment. The more complex your environment, the better that you split out the different roles and therefore use one of these things. So I hope that better explains it. Now, as I mentioned already, I already alluded, Elasticstack can monitor both VMs and Kubernetes environments, okay? Whether it's the resources or the underlying nodes. Elasticstack itself, the product, the Elasticsearch, Kibana, and the integrations like Logstash, APM, Beats, etc. The product itself, or there's all these separate products in one, they can be installed either on VMs or on Kubernetes. There is a new Kubernetes product. It has an operator as well. It's called Elastic Cloud on Kubernetes. So it doesn't matter which way you do it. You can have it installed on VMs and monitoring Kubernetes. You can have it installed on Kubernetes and technically monitoring VMs. You can have it both ways, every single way you want it. What I'll say about Elastic, the company, is that they do have very solid documentation and also training materials. In particular, I like their videos. They got like good developer advocacy on there. So I recommend after this, if you want to know more, go check out their videos. Have a look at this diagram. I can't show it because it's copyrighted, but if you just go to this link, you might find this very interesting. It shows you at scale what it might look like to have Elastic Cloud in AWS. Pretty interesting. You may also have heard of EFK. What does that stand for? The F, by the way, is not FileBeat. It stands for Elasticsearch Kibana, and the F is FluentD. And FluentD is a type of log collector. So, I mean, it's basically, instead of FileBeat, then they're using FluentD to collect their logs. Now, quite why they're doing that, I don't know, but this is quite popular, so there must be some reason behind it. I've never really looked more into it. Maybe it might interest me one day. So yeah, I'll be kind of curious. Maybe you know, maybe you want to leave a comment about that. Notice in here that in EFK, because there's no L, right, it's implied that there's no Logstash, so there's no data pipeline. And remember, like I said, you don't necessarily need Logstash. It is not a store. Stash means store in the real world. It is not a store for your logs. Elasticsearch is the store for everything, metrics, logs, and traces. So you don't need Logstash, and indeed, in many cases, many companies are not using Logstash. They've just got Elasticsearch because you always need a store. They've got Kibana because you always need a UI, although you could use a different one. And in this case, they're using for their collection FluentD, but it could easily be FileBeat or something else. So I just wanted to let you know what EFK is because you might see that a lot. Now we're moving on to Grafana Labs products, and I also want to include Prometheus, because Prometheus isn't by Grafana, although they're probably kind of jealous of it because it's an amazing a metrics product. So these kind of products, they're popular with startups and scale-ups and other non-enterprise because they're not typically designed for on large scale. They're not designed to be clustered, although you can cluster them. You can have high availability and stuff like that, but they weren't typically designed for that. I guess they were designed originally, like many open source products, just to be used in a pretty small scale environment. But you can go up to scale-ups with no problem. They are really, really good products. And especially, we're going to mention, you'll see here, Prometheus and Grafana, you're going to hear again and again and again. I'll let you know straight up ahead of time that Prometheus is a metrics product, probably the best one out there, and Grafana is a UI. So remember, we covered Kibana before, but Grafana is considered way better. A lot of people will call this, like, when you say Grafana, they'll just think dashboards, because the dashboards are really great with this. Now note with this, right, these other products, not Elastic, but Grafana and Labs and Prometheus type products, there is no unified open source install to install an entire observability stack, which remember is monitoring plus alerts, logging and tracing. There is no such thing. It's kind of crazy that in this day and age, there is no simple single Helm chart that will do for almost everybody the entire observability stack. What that means is you're going to have to construct this yourself, and it's going to require a lot of troubleshooting, debugging, tearing your hair out, and some time until you get it stable. And that's just the way it is. The nearest thing that you can get to it, the next best thing, is that there are 3 common Helm charts that you can install in combination. We're going to look at these 3 in turn now. The first one is called LGTM stack. Sounds like looks good to me, but that's not what it means. You'll see what it means. And there is a single Helm chart for this. Or there are separate Helm charts. And actually, it's okay to install separate Helm charts. Like many other products, they actually tolerate each other quite well. You don't actually really need the full thing. There is another one called Prometheus stack and another one called K's monitoring. So these last 2 are more dedicated towards monitoring. This first one, less so. This will become clear. I'm going to show you now. Let's have a look. I'm going to start with LGTM stack. All of these products I'm going to tell you that make up LGTM, they're all made by Grafana Labs. Okay, you got Grafana. I mean, yeah, that's their name, right? That's what they're most famous for. Their UI, their dashboard UI. Very popular, very good. You got Loki, which is a log aggregator. Aggregator just means to like piece things together and put as one. So it's a log store basically. You've got Tempo. The T is a clue. It's for tracing. It's for storing traces. And you've got Mimir. Again, the clue is the first letter M, monitoring. Mimir monitoring. Loki log. Tempo tracing. Mimir monitoring. Again, it's a store. By the way, monitoring stores in general, they're also known as time series databases, right? And Mimir, by the way, is also for storing long-term metrics. That's what it's famous for. This will become clear later on. So look at this. You've got a UI, and then the other 3 are all stores for their respective thing that they're storing: logs, traces, or metrics. Now contrast that to Elasticstack, which had a store which also was a search analytics engine. It had a UI and it had a data processing pipeline which was kind of optional, Logstash, right? So very, very different. It had one store, whereas this has 3 different separate stores and a UI, and it doesn't have a data processing pipeline. Now, what this LGTM stack is missing is missing collectors. So here are the collectors you're also going to need. Now, this may not be 100%. It may be that they have some collecting capability built in. But in general, from what I understand, is that you really need these collectors. So Promtail is a very common one. That's also by Grafana Labs, so you can expect some good integration. However, another common one is FluentBit. Now, there are other ones, but these are the 2 main ones that I want to suggest. For traces, OpenTelemetry Collector is considered to be the best way. OpenTelemetry is a very interesting thing, by the way. I recommend looking that up. Or more advanced use cases, which you don't need if you're really doing simple things, are Jaeger and Zipkin. But this is really more advanced use. It may be too complex if you're really just doing simple things. If you're just starting with traces, I would stick with the first one. And then for metrics, Prometheus is recommended. Now, I understand that Mimir can actually collect some metrics, but it's actually recommended. Prometheus has this amazing ability to scrape metrics, and it's complicated. I don't have time to really go into it, but it's actually recommended to use Prometheus with Mimir. You can actually have Prometheus on its own, and many companies only use Prometheus. But one downside of Prometheus is that it's not intended as a long-term store of metrics. It's really great at scraping and is only intended for short-term storage of metrics. So actually, if you already have Mimir and you use Prometheus, you can use the scraping ability of Prometheus and the long-term storage ability of Mimir. So that's why Prometheus is recommended to use even with the LGTM stack. So this is a great stack, but the one thing that it really is missing is the monitoring. I mean, I did mention it is recommended to use Prometheus, but if you don't use Prometheus, it's not really great for monitoring. It's almost like you need to install Prometheus with it. So the install is called LGTM-distributed, or as I said, you can install it separately and low-key distributed, and there'll be a tempo and a Mimir chart, etc., etc. So that's the LGTM stack by Grafana Labs, and the monitoring, you should really install Prometheus as well. Let's move on. Then you got another stack called Prometheus stack, and this is the first of the two monitoring stacks. So this is a great monitoring stack. And the reason it's great, you can guess it contains Prometheus, but it's a lot more than that, right? It has got some really useful CRDs. It has got an operator, which really helps. It just takes away a lot of the management. It comes obviously with Prometheus set up in like kind of highly available capability, and also some rules. It's got Alert Manager in there. You need this to fire off alerts to other external interoperability. It comes with Grafana as well, and with some really useful dashboards that are really useful for Prometheus and monitoring. It also comes with these as well. So these here are types of Prometheus exporter. Node exporter allows you to get the underlying node hardware and OS metrics. Black box exporter. A lot of companies use this. You can use this to health check external endpoints, HTTP endpoints. You can check certificates for expiry and that type of things. It also comes with something called kube state metrics, and this exposes the metrics from your Kubernetes objects or the resources. So it comes built in with this. Basically, it's a great stack. It is a great, good to go, immediately ready to use. Will get you in a great state in terms of monitoring if you install this stack. Now, obviously, it's got nothing with regard to logs and traces, so just wanted to mention that. Now, the other stack that's kind of similar, another great monitor stack, is one that's actually made by Grafana. So you can see here that they knew that the LGTM stack needed something else, really. So they made their own monitoring stack. Now, how is it different? Well, they didn't install Prometheus. They still want their other product. What was it called? Of course, it was called Mimir. I forgot for a moment. They still want to promote Mimir. I mean, it's kind of hard when you build a product like that, and everyone knows that Prometheus is better. But what are you supposed to do? I don't know. It would take a lot to start to they'd have to abandon it and say, okay, we accept Prometheus is better. They're not doing that. They got this case monitoring Helm, their own chart, and it is for monitoring, and it contains Grafana Alloy instances. So what these are is Alloy is their unified collector, and it can collect all kinds of things. But the idea is that you can use this collector, and it will scrape instead of Prometheus. So it will scrape for metrics. This is kind of similar, if you remember, to the Elastic Agent, which was a unified collector for scraping metrics, traces, and logs. So Grafana Alloy is Grafana's own unified collector, and you can use this instead of Prometheus in order to scrape. Now, it also comes with Node Exporter. We mentioned that already. It comes with kube state metrics built in. We mentioned that already. Anyone can put these in their own Helm chart. It's very useful. And it doesn't come, though, however, with Grafana. And that's kind of obvious because Grafana, they already have it in another stack, or they just expect, well, if you need Grafana, then go install it yourself. So it's not really a big deal that they didn't package Grafana into this Helm chart. And there are also some other minor items. There's some kind of cost control product and something else in there. But anyway, you can see that it's kind of similar. You can see that they knew that LGTM stack did traces, it did logs, but it wasn't really, it was missing something with regard to metrics. So they made this, although they didn't put Prometheus in here, but they kind of approximated the same thing as the previous chart. So yeah, definitely not bad. Now, here are some remarks I've got on this. I would say that Prometheus and Grafana, if you're not going the Elastic way, if you're going this way, Prometheus and Grafana, they're almost must-haves. They're such great products, okay? I know a lot of people have a lot of different opinions in DevOps. But there's almost unified opinion that Prometheus and Grafana are must-haves. Some other things to say. Instead of Mimir, to store metrics long-term, you might want to consider Thanos. Some people do. You may want to consider Grafana Alloy as a unified collector instead of having those other collectors that we mentioned, like Promtail, etc. There is some criticism of Grafana Labs that the integration in the docs, and you can already see this, right? Like, you've got LGTM stack. Well, why didn't they throw monitoring in there? So some people are like thinking, well, you know, are they unified? Do all their products really work together? You know, they didn't even, like, why didn't they make a whole observability Helm chart? There are people, by the way, asking for this on GitHub and say, do you have any plans to release an observability Helm chart that will do everything, metrics, logs, and traces? And I think I read there something like they just basically don't have any plans. So it kind of tells you something about how the company operates, right? It's a little disparate. I don't know. It's a little bit strange. It would be better to have better unification and integration. But, you know, I'm not complaining too much. And also, some people complain about their quality of documentation. For me, it's been okay, but I got to say, it's not as good as Elastic's. Now, I know you're wondering, if you want to install this stack to do your entire observability solution, how do you do it? Well, you're going to have to do it yourself and figure it out, but there's a couple of clues I can give you. And one is, the thing that I've heard both times is, don't install the LGTM full Helm chart. Install the separate Helm charts for each LGTM like that. So install separately LGTM, and then Alloy, and then the Prometheus stack. Okay, that's one way. And then another way I've heard is to install the case monitoring Helm, if you prefer that instead, and then the LGTM separates. So these are two ways that I've seen people talk about. And yeah, very interesting. What I will say is, my next video, my part 2, I'm going to attempt to do one of these two and get it working and share with you how I did it. And I hope that's going to be super useful. Until that video, you may want to try it yourself. There is an interesting diagram here on the Grafana website. Again, it's copyrighted, I can't show you, but have a look at this. It's quite a cool diagram that you might find quite interesting. It just shows you how the LGTM product works and what it looks like in a diagrammatic form, which is quite good for visualizing. Go watch some videos, whether they're Grafana Labs videos or Elastic videos, and I will have my own video coming soon, like I mentioned. Hope you enjoyed this video. If you did, please give it a thumbs up. We're almost at 200 subs and we're almost at 100 videos. I really enjoyed making this video. I hope you got a lot of great value out of it. If you got any questions, please leave them down below. If you enjoyed this video, please give it a thumbs up. You know how it works. It really helps with the whole algo and all that kind of stuff. Subscribe to the channel. Come back for more. Support us. Post about this channel to Reddit, to Slack, and to anywhere you think people are going to benefit. We'd really appreciate that. And I will speak to you again soon. Take care. Bye-bye.